All right. For our online students, we're on page 323, working the Chapter 5 practice test. And this test is 5 pages long, so you want to take lots of good notes and bring them with you to the test. And the first question on page 323 says, tell whether the underlined item is used as a cardinal number, an ordinal number, or for identification. So bring your definitions with you. Cardinal means what? How many? Like cards, counting cards. Ordinal means what? The order that you put things in. And identification means it's used to identify something. So when it says Sally came in third in the 100-yard dash, is that her identification number? Is that how many students were in the race? Or is that the order? Order. So A is order. Bill's lottery ticket won $2. So that's telling you how much. So that would be what? Say the word. Starts with a C.
Cardinal.
Cardinal, right? Just say that doesn't make sense. I know. Just attach the word cardinal to how much or how many. And then Jane's auto license number. How do you know that's Jane's car in the parking lot? Identification. That's her license number. Okay? Question 2. And those definitions are on page 230. Question 2, skip it. It's not on the test. Question 3. Write 1,220 as a product of prime numbers. So you build a tree, 10 and 122, 5 and 2 and 2 and 61, and bring your prime number chart with you. Where'd mine go? Here it is. Bring your prime number chart with you to the test. If you don't have one, Google prime numbers and print one off. And because then I look and say 61's on my prime number chart, so I don't have to try to factor it. And how do you write this? Over here, 2.2.5.61, or it might be written 2 to the second power. And both of those mean the same thing. Number 4. A prime number, write the prime numbers between 50 and 70. You just pull up your prime number chart and go to 50, and it's before 53, and then you go to 70, and it's after 67. So you go 53, 59, 61, 67. You just get a prime number chart. Because you don't have time. With a 5-page test on next Monday, you don't have time to sit down and figure it all out manually. Just bring your prime number chart with you. Number 5 is 143 prime or composite. Check the chart. 143. 139, 149. So what does that tell you? If it's not on the chart, what does that make it? A composite number. Number 6. Do you know your division rules? How do you know if it's divisible by 2? It ends in an even number. How do you know if it's divisible by 3? That's the one you don't have memorized, so write it down. You add the digits up, and if the digits are divisible by 3, the number is divisible by 3. Just write that down and bring it with you. How do you know it's divisible by 5? It ends in what?
5 or 0.
5 or 0. See, somewhere, somebody in life made you memorize the 2 and the 5 thing, and they decided that the 3 thing wasn't important. So you don't have to memorize it for the test, just have it written out. And if you don't know the rules for 2 and 5, write those out too and bring them with you. So in 2, 3, 4, 5, you say, well, it ends in 5, so it's divisible by 5. and it's not even, so it's not divisible by 2. Is it divisible by 3? Well, what's 5 and 4 and 3 and 2? 9, 10, 11, 12, 13, 14. Is 14 divisible by 3? No. So it's only divisible by 5. Number 7. Find the GCF. You know what GCF means?
Greatest common factor.
The greatest common factor of 216 and 254, and then reduce the fraction. So I have two things to do here. Let me change to blue. I have to find the greatest common factor, and then I have to reduce the fraction. Well, how do I find the greatest common factor? Build two factor trees. 216 is 3 and 72, and then 3 and 2 and 36, and then 3 and 2 and 6 and 6. So now, oh, and 6 becomes 3 and 2 and 3 and 2. So now I have the prime factorization of 216 is 3, 2, 3, 2, 3, 2. What's the prime factorization for 254? 2 and 127. And you can spend time messing with 127, or just look at your prime number chart and say, 127 is a prime number, so I'm done with it. Now, are there any common factors between this list and this list? Say, yeah, there's a 2 in here, and there's a 2 in here. So that means I can cancel out those 2's, and that leaves me with 3 times 3 times 2 times 3 times 2, which is 108 over 127. And that's the B part. That's reducing it down. Number 8. Find the LCM. What's LCM?
Least common multiple.
The least common multiple. So multiples of 18 would be 18, 36, 1 times 18, 2 times 18, 3 times 18, 4 times 18, and ... You follow what I'm doing? I just make a bunch of multiples of 18. Then multiples of 54 are 54, then 108, 1 times 54, 2 times 54, 3 times 54, and ... And then 60, multiples of 60 are 60, and then 120, then 180, and ... And I just keep stringing out the list until I find the one number that's in all three lists. Or I can use factor trees. And 18 is 2 times 2, 3 times 3. So my least common multiple is going to have a 2 and a 3 and a 3 in it, because it has to have this number. And then it also has to have, let's change to green here, it also has to have this number in it. Well, I already have a 2, a 3, and a 3, so I just need one more 3. Everybody follow that? So now, this least common multiple has the first number in it and the second number. So now what about the third number? Do I have another color here? No, it doesn't look like it. What's that all about? So let's just go back to black. I need a 2, a 3, a 2, and a 5. I have a 2, a 3, I need another 2, and I need a 5. Everybody follow what I just did? Now I've made this box contain all three numbers. 233 in blue, 2333, 2333 in blue and green, and then 2325, 2325. I already had a 2 and a 3 in there. I just need to add the 25. Then the question is, what is this number? And that number is 540. 3 times 3 is 9, times 3 is 27, times 10 is 270, times 2 is 540. So if you would have made this list, if you would have come up here and kept written these, if you would have kept working these out, you would eventually come up with 540. What's that all about? My goodness. I did something that bothered the computer. So you would have come up to 540 in all 3 lists. And you would have seen that all 3 are there if you want to do it that long, strung out way. But remember, we've got a 5-page test to take on next Monday, so you kind of want to figure out the fastest way to work through them. And then, after I've done that, what did it tell me to do? And then, so that was A. I just found my least common multiple. Then they want me to come down here and evaluate these fractions. So my common denominator is 540. Maybe put it down here. 540. 540. 540. And what do I take times 18 to get 540? 30. So that means I also take 30 times 1, and I have a new numerator, 30. And what do I take times 54 to get 540? 10. So I take 10 times 1, and I get 10. Now, if the numerator was 2, 10 times 2 would be 20. You see, it just happens that they put 1 in all the numerators here. And then what do I take times 60 to get 540? 9. So that comes out to be 9 over, take this times 9 times 1. So now what's 30 plus 10, 40 plus 9? No, minus 9. Wow. 30 plus 10 is 40. Minus 9 is 31. So there's your answer. 31 over 50, 540. Number 9. A father left 1/4 of his estate to his daughter, so I put down the 1/4. 1/2 to his wife, so this is the daughter's inheritance, this is the wife's inheritance, and 1/8 to his son, this is his son's inheritance. If the rest went to taxes, and this is taxes, say, well, I don't know what it is, then put an empty box in there to represent taxes. Then what fraction of the estate was that? Well, 1 is the whole estate. So 1/4 plus 1/2 plus 1/8 plus 1 whatever would equal 1 whole thing. Well, now I get common denominators. 2/8 plus 4/8 plus 1/8 plus, and I'm going to take this out for a minute and say, plus how many 8s would equal 8/8? 4, 5, 6, 7, and that would be 1 more 8. You see what's going on? Number 10. Change the following to equivalent addition problems. So the first thing I do is change it to an addition problem. 8 minus 19 is 8 plus negative 19. Remember that? 8 minus this is 8 plus the opposite of that. So in every one of these, I change them to an equivalent. I change the subtraction to an addition problem. And then I come back and give the result. And what's 8 plus negative 19? Negative 11. What's 8 plus positive 19? Positive 27. And when you look at 8 minus negative 19, in your head, that probably doesn't look like positive 27. That's why you want to convert these subtraction problems to adding the opposite. So you won't get confused, because you try to do subtraction with integers in your head, and you'll probably end up making a mistake. And then negative 8 plus negative 19 is negative 27. And see, once you've converted it from a subtraction problem to adding the opposite, then it's more obvious and you're more willing to accept it, and you're not going to be as tempted to pick another answer. Because what do you think? Will he have other choices on the test that would make you feel good? That would probably be wrong. Yes, he's been doing that all semester, so he just keeps it up. And negative 8 plus 19 is positive 11. Number 11. Evaluate 4 times 12 divided by 3 times 10 to the third minus 2 parentheses negative 6 minus plus 4 parentheses times 10 to the fourth. So your order of operations. Do you have your order of operations written down in your notes? What's the first thing you do? Exponents. Let me change that to blue. First thing you do is exponents. So now 10 to the third is 1,000, and 10 to the fourth is 10,000. Then what's the next thing you do? You do whatever's in the parentheses. What's negative 6 plus 4? Negative 2. Then what's the next thing you do? Multiplication and division, left to right. So I start up here and I go 4 times 12 is what? 48. And divided by 3 is what? 16. And then 16 times what? 1,000. That's 16,000. Over here, 2 times negative 2 is negative 4. Negative 4 times 10,000 is negative 40,000. 16,000 minus a negative 40,000 is 16,000 plus a positive 40,000, which comes out to be 40 and 16, 56,000. Everybody follow that? Write those rules down and keep them straight.
Aren't you supposed to do the parentheses first?
What?
Aren't you supposed to do the parentheses first?
And we did that up here. See up here? Negative 6 plus 4 is negative 2.
Okay.
So we did that. And we also did the exponents. 10 to the third becomes 1,000. 10 to the fourth becomes 10,000.
Yes.
Number 12. Skip it. It's not on the test. Number 13. Find the reciprocal of 2/3. Here's what reciprocals are. A number times its reciprocal. A number times its reciprocal equals 1. So what would I take times 2/3 to get 1 for an answer? 3 halves. Everybody agree with that? So what's the reciprocal of 2/3? 3 halves. Negative 4 over 7 times what? Would equal 1. Negative 7 over 4. Everybody follow that? So, negative 7 over 4 is the reciprocal. 2 and 5/8, I don't work with those mixed numbers. I don't like them. So I change it to 21 over 8 times what would equal 1? 8 over 21. Okay? D, negative 8, that's negative 8 over 1. I need a fraction. So I change it to negative 8 over 1 times what would equal 1? Negative 1 over 8. Everybody see how that works? Number 14. 7/8 times negative 5/16 is 7 times negative 5 is negative 35. 8 times 16 is 128. Can I reduce that down? Well, negative 35 with the factor tree becomes negative 5 and 7. 128 becomes 4 and 32. Am I going to get a negative 5 or a 7 out of 32? So it looks like that's lowest terms, or my final answer is negative 35 over 128. Let's do 14b. Negative 7/8, and now it's divided by negative 5/16. Well, division is times negative 7/8 times the reciprocal. So I flip it over and make it negative 16 over 5. A negative times a negative is going to be positive. Now, see here again, when we went through this section, I told you, you can save yourself some work by going, okay, this is going to be 7 times 16 is the same as 8 times 2. And then underneath, I put the 8 and the 5. And why did I factor them like that? Because the 8's will cancel. So that leaves me with 14 over 5. Because 8 over 8 is a name for 1. So that's why instead of multiplying 7 times 16 and getting what? 112 over 40, and then having to go back and factor them and reduce them again, I just say before I put this stuff together, let's factor it and see if there's anything that'll cancel. Number 15, skip it. That's not on the test. Number 16, calculate means do this multiplication problem. So what's 6 times 8? That's easy, that's 48. What's 10 to the 4th times 10 to the negative 6? What do you do when you multiply exponential numbers? Add the exponents. 10 to the negative 2. But look what it says next for number 16. Write your answer in scientific notation. 48 is not scientific notation. Scientific notation, remember, is a number between 1 and 10. So I have to change this to 4.8 times 10 to the first. So now I have 4.8 times 10 to the first times 10 to the negative 2. So what does that come out to be? 4.8 times 10 to the first times 10 to the negative 2. Add the exponents would be 10 to the negative 1. Now it's in scientific notation. That's what they're looking for. And if on the test, one of the choices was 48 times 10 to the negative 2 and you picked it, it would be checked wrong. because they said put your answer in scientific notation. And 48 times 10 to the negative 2 is not scientific notation. You say, yes, but it means the same. Well, to say my name is Tom Bonine with small t, small b means the same as my name is capital T Tom and capital T Bonine. But what does your English teacher say if you spell my name small t Tom and small b Bonine? What's the rule? See, you people are willing to accept these rules in English. Comes to math, and I give you some rules on mathematical protocol, and you get all bent out of shape. But you let English people tell you all day. And the disgusting thing about English is to make it capital T and capital B, it takes 2 more motions when you're typing, right? On the keyboard, you have to hit the shift key. I hate the shift key. It just wastes too much time. So I just don't use it. You go, yes, but you violate the rules of English. So what are you going to do to me? I spell my name with small letters because I don't like wasting time hitting shift keys. But when it comes to math, no exceptions. You do it the right way. Number 17, just use your calculator. What's 6 point? How could you miss these by using a calculator? Forgetting the decimal point, hitting the wrong key, confusing addition and multiplication or division. So just bring a calculator with you. Don't you have one on your telephone? If you don't, then bring a calculator with you and just use your calculator to do those problems. Number 18 says the 3 sides of a triangle. So that means, did I build a triangle out here? No. Well, let's build one, just so you can see what they're talking about. Our 18.7, 6.25, and obviously my triangle's not drawn to scale, and 19.63. But I get the idea. And then it says, what does it say? What's the perimeter? And what does perimeter mean? The distance around. So you add the 3 numbers together. And if you add those 3 numbers together with your calculator, you'll get 44.58. And that will be one of the choices on the test, and it will be wrong, because look what it says to do. Oh, it doesn't say it in your practice test. So I wrote a note in my practice test. On the exam next Monday, it's going to say, what's the perimeter of the triangle to the correct number of decimal places? That's what it's going to say on the test. To the correct number of decimal places. So, do I put 44.58 or do I put 44.6? Why would I round it to 3 places? Because the most accurate measure has 1 decimal place or 3 significant digits. So I only have it measured to the nearest tenth, because I don't know what this is to the hundredths. So I can't give my answer in hundredths because this one was given in tenths. So the most accurate measure I can have is to the nearest tenth. All right. Number 19. The dimensions of a college basketball court. Did I draw a picture of that one? Well, you know what it looks like, don't you? 93.5 and whoops, got them backwards. 93.5 up here and 50.6 here. And what's the area? How do you find the area? Length times width. So you multiply those two together, and you get 4731. Where's my calculator? Is that what you get? Yeah, I think so. 93.5 times 50.6 equals 4731.1. But my note here says on the test it's going to say to the correct number of decimal places. Say, well, that's to the nearest tenth. But it didn't say to the nearest tenth. It says to the correct number of decimal places. And there's only 3 significant digits here and 3 significant digits here. So my answer can only have 3 significant digits. So the correct answer is 4,730. If it would have said to the nearest tenth, then I would have said 4,731.1. But if the test says to the correct number of decimal places. So when it says that, you have to use that rule for significant digits, and you can go back in the book to find that section and write down those rules so you can get it right on the test. Number 20. Write the following as a decimal. You just take 3 divided by 4, and it's 0.75. What about 1 over 15? Take 1, divide by 15, and it just keeps going. So how do you write it? Well, the 6 is what repeats, so you put a line over the 6. Number 21. Write the following as the quotient of 2 integers. 0.12 with a line over the 0.12. Have you figured that out? That's just going to be 12 over 99. Remember that little shortcut I was showing you the other day? If you don't, then you let 100 in equal the number 12.121212, and then n is 0.12, then you subtract and you get 99 in equals 12. So that means the number is 12 over 99. And do they tell you to reduce it down? No, but they probably won't show 12 over 99 on the test. They'll show 4 over 33. But you would know that if you had 12 over 99, that would be 4 over 33, right? .65555. The 5 keeps repeating, but since it was 2.6, I want to get rid of those decimal places, so I just used 100 times that number and got 265.5555, and then I took 10 times that number to get 26.555. See, that way my 5s are going to cancel out, and it's going to leave me with 239 equals 100 minus 10 is 90n. So n is 239 over 90. And can I reduce that down? Is 239 on my chart? Sure enough. See why you want to bring that prime number chart with you? 239 over 90 is my final answer. Number 22. Write 21% as a decimal. So, what does percent mean? Percent means per 100. So 21% is 21 over 100. As a decimal, that would be 0.21. Everybody follow what's going on? But if you learn the rule, the decimal point for 21% is right there. If you want to drop the percent sign, you move it 2 places to the left and drop the percent sign. And it's 0.21. If you want to drop the percent sign here, then you move it over 2 places, have to add a 0, and it's 0.0935. If it's 0.26%, then if I want to drop the percent sign, I have to move it over 2 places. And that comes out to be 0.0026. Number 23. Write the following as a percent. Well, then you just move it the other direction. 0.52. 0.52 is really 52 over 100. Agreed? 0.52 is 52 over 100, which would equal 52%, which is the same as just moving the decimal point 2 places and adding a percent sign. That's true of all of these. Move it 2 places and add a percent sign. Move it 2 places. Oh, I have to first change it to 0.6 and then add a 0 so I can move it 2 places and add a percent sign. What's 23D? 2 over 11. Oh, that comes out to be 18181818. But if it's point all of that, then I just move it over 2 places, and then I have 18.181818%. But they said to 1 decimal place, so that means I have to either make it 18.1 or 18.2. And which is 18.18 closer to? 18.2. So I make it 18.2%. Number 24. A 2-liter bottle of soda sells for 86 cents. Yeah, this is what it sells for. Okay? I don't know why people get messed up on this. This is what it cost, 48 cents. So if you pay 48 cents for it and you sell it for 86, your profit was 38 cents, right? That's clear to everybody. Okay, watch what the next thing it says. Find to 2 decimal places the percent of profit on the cost. So they're already telling you the profit on the cost, the profit would be the 38, on the cost would be the 48. You follow that? You always calculate profit on what you paid for it, not what you sold it for. So what's 38 over 48? Well, let's just go 38. 38 divided by 48 equals 0.791666. So it looks like 6 just keeps going. So now they want this to be changed to a percent. So I go 79.166 0.66%. But they want it to, what did they say? To 2 decimal places. So they want me to go to 2 decimal places, so I make it 79.17%. See what's going on? Read the directions carefully. Number 25. About 4 million women make between $25,000 and $50,000 annually. So I have 4 million women who make this much money, and this 4 million represents or equals 15% of all the working women. Of means times, change percent to a decimal. A is all, and 4 million. So how do I find out how many people are working? If 4 million is 0.15 times that, then A would be 5 divided by 0.15, or with 4 divided by 0.15 is 26.666 million women. Did it tell me to round it to a certain place? What's the total number of working women? Well, if it said 4 million, then I would say about 27 million. 26. Classify each number as rational or irrational. Do you have a chart with your perfect squares? 4, 9, square root of 16. Bring that chart with you. And the square root of 49 is 7, so that's rational. The square root of 45 is between 49 and 36, so that's irrational. And 121 is on your list. Its square root's 11, so that's rational. So just bring your square root chart, and any square root that falls between those perfect squares is going to be an irrational number. Now it gets a little tricky. So what happens here? 25, 25, 25. So that's a rational number because it repeats. But look at this. Here's 2, 1, then here's 2, 1, 1, here's 2, 1, 1, 1. I see a pattern. The next one would be 2, 1, 1, 1, 1. You follow me? But that's a pattern, but it doesn't repeat. You don't have, it's not 2, 1, 2, 1, 2, 1, 2, 1. So that makes it an irrational number. Watch out for that. F, there's no pattern, so it's an irrational number. F, it keeps going, but there's no pattern to it, so that makes it an irrational number. And G, there is no G. Oh, I made one up. It terminates, so that makes it rational. And H, this number terminates. See, that's what you have to watch for. Up here, that 2, 1, 2, 1, 2, 1 is irrational because it had dot, dot, dot at the end of it. Down here, if I have this with nothing, if it terminates, that makes it rational. So watch out for that. 27, a rational number between 2/10 or between 2, 2. Then you just simply go, okay, so just stretch it out. And 2, 2 and 2, 5, and that would be 2.23, 0.24, etc. Number 28, the diameter of a hamburger is 4. What's the circumference? Circumference is pi times diameter. So I take 3.14 times 4, and I get 12.56. But read carefully. Oh, to the nearest 1/10 of an inch. So to the nearest tenth of an inch, the correct answer would be 12.6. Watch out for that on the test. 29. The circumference of a basketball is 29. So now they're telling us what the circumference is, and they want us to find the diameter. So circumference is pi times diameter. So 29.5 equals 3.14 times d. So d would be 29.5 divided by 3.14. And what does that come out to be? 9.3949044. And what do they say to do? Oh, on the test it'll say to the correct number of decimal places. And since there are 3 significant digits, then you only go out to 3 significant digits, which would be 9.39. Number 30. Simplify, make a tree, and look for perfect squares. And there's a perfect square. So the answer is 4, the square root of 16, times 2 times 3 is 6. 58. There's no perfect squares to pull out, so the answer is 58. So you can't simplify. 31. Oh, rationalize the denominator. When they say simplify and you've got an irrational number in your denominator, you take the top and the bottom times that, and you end up with 4 radical 20 over 20, and 4 puts 5 down here, and 20 becomes the square root of 4 times the square root of 5. This becomes 2, so the answer is 2 times the square root of 5 over 5. 48 over 49. Square root of 49 is 7. 48 is 3 times 16. 16 and square root of 16 is 4. So it's 4 radical 3 over 7. 32. Multiply. 6 times 8 is 48. But that's 16 times 3. So that becomes 4 times the square root of 3. (32b), 56 divided by the square root of 7. 7 doesn't go into 56, so I have to rationalize the denominator. It doesn't tell you that, but when it says simplify, that's what it means you do. So I take the top and bottom times the square root of 7, and I get 56 is 4 times 14. And then square root of 7 times the square root of 7 is just 7. So now I have 14 is 2 times the square root of 7. So I end up with, this becomes 2. 2 times the square root of 2 times the square root of 7 times the square root of 7. Well, that would be the square root of 49, which equals 7. So the answer, oh, this 7 cancels with this 7, so it's 2 times the square root of 2. Number 33 says subtract. I can't subtract unless I have the same kind of radical. So 90 in a tree becomes 3 radical 10. 40 becomes 2 radical 10. 3 of these minus 2 of these equals 1 of these. 32 becomes 16 times the square root of 2, 9 times the square root of 2, and 25 times the square root of 2. So I have 4 of these, 3 of these, and minus 5 of these. 7 minus 5 is 2 times the square root of 2. Number 34. The length of the hypotenuse of a right triangle is given by, they give you the formula and they say this C is the hypotenuse. So plug the numbers in. If a right triangle sides measure 4 and 6, you put 4 in here for A, and b, and then 4 squared is 16, 6 squared is 36, 16 and 36 add up to 52, and that becomes 4 times 13, so that's 2 times the square root of 13 is your answer. Skip 35. It's not on the test. 36. Okay, 36 says classify A 2486, 24,816 as arithmetic or geometric. Arithmetic means you do what? You add or subtract. Geometric means you multiply. How do you get from 2 to 4, from 4 to 8, from 8 to 16? You multiply by 2, so what does that make it? If you multiply, it's geometric. So there are going to be 2 questions on the test, and it'll say which one of these is an arithmetic sequence and which one of them is a geometric sequence. And here, 5 to 8 to 11 to 14, you add 3 each time. So if you add, that makes it arithmetic. So just put in your notes, it's an arithmetic sequence. If you add or subtract, it's a geometric sequence if you multiply. 37. Find the sum of the first 10 terms. 9, 13, 17, 21. So we're adding 4 each time, so let's just keep adding 4. 25, 29, 33, 37, 41, and 45. So what do they want me to do? Find the sum of the first 10 terms. So I just add 45, 41, 37, 33, 29, 25, 21, 17, 13, and 9, and I get 270. You understand how that works? Oh, you say you want to use the formula? Okay, there's the formula. The sum of the first n terms is the number of terms, 10, times the first term plus the 10th term, divided by 2. And you end up with 270. And number, what? $38. Skip 38 through 40. Okay. That's what it says. Skip 38 through 40. Whew. There's a whole bunch of stuff to do all at once on the test. So bring lots of notes with you. Take a deep breath and be careful. And don't let the guy who puts bad answers out there distract you from what you know what to do. Have a nice Easter weekend. I'll see you on Monday with a 5-page exam over chapter 5.